What's up? Today we are talking about something called multiplication as scaling. Now, I will share that this is not a concept or a topic that I myself learned in school, but it is something that is being taught now in many places, and I think it's pretty cool actually. So let's first start by what this language of scaling means. Scaling. So to scale something in this context, it means to resize or change the size. If you scale something up, you're making it bigger. If you scale something down, you're making it smaller. And where does this happen in real life? Well, we scale things up and scale things down all the time. For instance, I don't know if you've ever played with Legos, but sometimes you can buy Lego sets that are miniature creations of something real. I think I once was in a store and I saw a Lego version of the Eiffel Tower and I've also seen a Lego version of many different things. Now, obviously, the Lego version of the Eiffel Tower, which is this very large, famous tower in Paris, is much smaller than the real tower, but the proportions are about the same, meaning that it's a scaled down version, a scaled down version of the actual Eiffel Tower. Architects will create model buildings using like on a table using plastic or other elements to build something to get a sense of what something looks like. And basically it's a scaled down model of something real. And another example, I'm trying to think where we might, I guess maps. Geographically speaking, we use maps are a scaled down version of the actual proportions of the different continents and countries and bodies of water. So I hope that that kind of helps you to understand what we mean by scaling. Now, how does this apply to multiplication? So basically, the notion of scaling is, let's say you have a number. In this case, we have 1/2, right? And we're multiplying it by another number, a fraction. In this case, we're dealing with fractions. When we multiply a number by a fraction that is less than 1, then the final product of those two factors will be less than that first factor. And so without me even having to, let's pretend we didn't know the answer here. We didn't know the answer. I would already know by looking at this equation, I would already know that my answer would be less than 1/2. Why? Because I am multiplying by a number that is less than 1. And what's really nice about understanding this concept and really getting it down is that not only can it help you make calculations faster and check your work to make sure that you got the right answer when you're dealing with, fractions, but conceptually it'll just help you with other math topics. And it's good mental math as well. So let me go to this example. In this example, we have a whole number. The whole number is 10. We are multiplying it by a number that is less than 1, a fraction, a proper fraction. And what does that mean? I am already going to know, without even answering the question, that my answer is going to be less than 10. And we know that that is true because when we actually do the calculations out, 10 times 4/5 is, let's do it out, is the same as 10 over 1 times 4 over 5, which equals 40 over 5. And 40 over 5 is the same as 40 divided by 5, and so that equals 8. So 10 is less than 8, and so over here it does check. Now, what if you are scaling up? Here, the same thing is true about multiplying by fractions that are greater than 1. You will actually, instead of scaling up, scaling down, you scale up. So if I have a number, 1/2, and I multiply it by another number that is greater than 1, my answer is going to be, whoopsie daisies, greater than 1/2. And so as we look at this problem, let's see if it checks. 1/2 times 20 over 2, or 20 halves, is the same as, it equals 20/4. And what is 20/4? Well, 20 over 4 is the same as 20 divided by 4. Remember that this fraction bar is the same as a division bar, and it equals 5. Now so my answer is 5. 20/4 equals 5. And that indeed is greater than 1/2. Let's look at this next example. Here we have 1/2 times 4. And without knowing the answer, let's pretend this isn't there. We see that 4 is a number greater than 1, and that's going to mean my answer is going to be greater than this first number, this first factor. And as we look, indeed, it is greater than half, because 4 over 2 is the same as 2, and 2 is indeed greater than 1/2, right? And finally, we've got 10 times 10 over 5. And remember, what that really means is 10 over 1 times 10 over 5. What do we get? We get 100/5, which is the same as 20, because 100 divided by 5 is 20, and 20 is indeed greater than 10, that first number. And finally, if you have a factor and you multiply it by a number or fraction that is equal to 1, the product will be equal to that factor. So this really is straightforward. It's the same notion that any number multiplied by 1 will be itself. So for instance, if I have 2 times 1, it's going to be 2. It's itself. If I have 2 times 3/3, it's also going to be 2. Why? Because 3/3 is the same as multiplying by 1. And let's say we actually wanted to see that done out. 2 over 1 times 3 over 3 equals 6 over 3, which equals 2. Let's do some examples. So this is from a worksheet that I gave my students. And let's start with this first one over here. 5 times 6/7. Is the answer going to be greater than 5, less than 5, or equal to 5? Well, when I look at this problem, I see that 6/7 is less than 1, which means the answer is going to be less than 5. 99 times 7/3. Now, 7/3 is an improper fraction, meaning the numerator is greater than the denominator, which means 7/3 is actually a number that is larger than 1. So 99 times 7/3 is going to be greater than 99, because the number that we're multiplying 99 by is greater than 1. And how about 2 times 3/2? Again, improper fraction here. 3/2 is greater than 1, so my answer is going to be greater than 2. Let's do a couple more examples. What if I have 10 times 2/3? Is my answer going to be greater than 10, less than 10, or equal to 10? If you said to yourself that it's going to be less than 10, you are correct. How about 25 times 8/2? halves. Is my answer going to be greater than 25, less than 25, or equal to 25? If you said to yourself that the answer is going to be greater than 25, you are correct. And last but not least, let's say I have 300 times 4/4. Is my answer going to be greater than 300, less than 300, or equal to 300? And if you thought to yourself it's going to equal 300, you are going to be correct. I hope you found that helpful, and that is all for today. Till next time.